We are moving on to the unit circle again today and finding some more things on the unit circle, adding that last piece to our unit circle and adding the coordinates in there. And so far what we've looked at is we started looking at the unit circle in degrees, and then we added that and we looked at the unit circle in radians as well. And now we're going to add the last piece to the unit circle where we add these coordinates in right here, xy coordinates. So we'll be working on that today. Okay, so this is kind of a unit circle without any markings on it. What I want you to think about is how this unit circle can be divided into triangles, and we will talk about that. What you need to know is that the radius on the unit circle, and as long as you are on the unit circle, the radius, this distance right here, is always going to be 1. So you're going to think of this as a coordinate grid, this being your y-axis right here. So this is your y-axis, obviously, and this is your x-axis here. And you're going to think of that circle being imposed onto a coordinate grid where the radius, again, is 1. Okay? So what you're going to do is you're going to need to, first of all, come up with some coordinates. And these 4 coordinates are pretty easy to do if you know the radius is 1. This is still the origin, so this is the point 0, 0 right here. And if the radius is 1, then if you've ended up right here, you've gone 1 to the right and 0 up or down. Up top, I think you can figure out that you will go 0 left or right and 1 up since the radius is 1. Over here, 1 to the left, 0 up and down here, 0, and then -1. Okay, so those are those 4 coordinates. I think those are pretty self-explanatory. Now we're going to look at the ones that are at the 45-degree angles, okay, and we're going to sort of figure out how we generate those coordinates. So I'm going to think of this, I want you to think of this as a triangle, and the coordinate that goes here is how far right I went and how far up and down I went. And so I know that both of those numbers are going to be positive, because to get right here, I need to go right and I need to go up, okay? So it'll be positive, positive. I know that this distance is 1 because it's the radius of the circle. I do not know this distance or this distance, but since it's a 45-degree angle, 45, 45, 90-degree triangle, I do know that they're the same distance, okay? I don't know what they are, but I know that they're the same. So I can use the Pythagorean theorem, and I can figure out what x is, okay? So I'll go like this. X squared plus x squared equals 1, or 2x squared equals 1. Divide that in half, so x squared equals 1/2. And then clearly you're going to take the square root of that, so you're going to take plus or minus the square root of 1/2. And actually we're dealing with a distance here, so we'll just call it positive for right now. When you take the square root of a fraction, you need to take the square root of the top over the square root of the bottom. And you can't leave a radical in the denominator. This is where all these fun radicals from Algebra 2 come back to haunt you. I cannot leave a radical in the denominator, so to get it out, I will multiply it by itself. So it'll look like that. So then the top, the square root of 1 times the square root of 2 is the square root of 2. On the bottom, the square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay? Some people think I can reduce those two 2's, but one's inside a radical and one is not, and so I cannot reduce them. So x is root 2 over 2. Okay? Which means this distance right here is root 2 over 2, and this distance right here is root 2 over 2. So the coordinates are, then, to get to this spot up here, I go right, root 2 over 2, and up, root 2 over 2. So positive, positive. Okay? Over here, what will happen, I think you can figure out, is that you'll go left root 2 over 2 and up root 2 over 2. Well, left is negative and up is positive. Okay? Down here, I have to go left and down. So left is negative and down is negative. Okay? And then over here, which I've written over, so I'm going to erase, I will go right and down. So right and down. Okay? All right, then moving on to the 30, 60, 90 degree kinds of triangles. So now this angle in here is 30 degrees. And I need to figure out my sides of my triangle, okay? So this distance right here is 1. We know that the radius is 1. So I know that the hypotenuse of my 30, 60, 90 degree triangle is 1. Some of you remember maybe your 30, 60, 90 degree triangle properties. If you do, that's fabulous. If you don't, I'm going to kind of give you a way to figure this out. You're going to need to memorize these numbers, so you're not going to have to sit and refigure these out every single time. You're going to have them. I just want you to know how they were generated, where they came from. Okay? So this is what I know. If I think about this whole side right here, then I would have a 60 degree triangle, 60 degree triangle, and a 60 degree triangle right here. So this whole side is 1, which means I can take that side and cut it in half because it's an equilateral triangle, and each half will be the same. So I know that this side right here is 1/2, but I don't know this side. Okay? So again, I'm going to do the Pythagorean theorem, and I'm going to do x squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 equals 1. So x squared is 3/4. So x is the square root of 3/4. We'll just call it positive right now. Technically it should be positive or negative, but we're looking for a distance, so we're going to call it positive. When you take the square root of a fraction, you need the square root of the top over the square root of the bottom. Square root of 3 I can't simplify, but square root of 4 is obviously 2. So that distance right there is square root of 3 over 2. Okay? So, now, to get up here, I am going to go square root of 3 over 2 to the right. Notice that's longer. That's a longer side. Square root of 3 over 2 to the right, and 1/2 up. So square root of 3 over 2 to the right will be positive, and 1/2 up will also be positive. Down here, I'll go square root of 3 over 2 to the right, and 1/2 down. Down would be negative. Okay, I think you can fill in the rest of these. I'm not going to take the time to do that, but that's how you generate it. Then we get to this, which is also a 30, 60, 90 degree triangle. It's just not, so this is my 60 degrees, this is my 30 degrees. Same kind of ratio. The only difference is it's just the triangle kind of turned a little bit. So this will be 1/2, this is 1, and this distance is a square root of 3 over 2. Okay? So to get up here now, I would go 1/2 to the right and square root of 3 over 2 up. And I hope you can fill in the rest of these. Like down here, I would go 1/2 to the left and square root of 3 over 2 down. So because I went left, it's negative, and because I went down, it's negative. And I just mix those up. 1/2 to the left and square root of 3 over 2 down. Okay? And you can fill in the rest of those. So this should be all of the coordinates now for your unit circle all the way around. This is what it should look like, filled in. Okay? Every degree, every radian, and now we have all of the coordinates. And now we kind of need to figure out, once we have the coordinates, what will we do with it? Okay? And so we use these coordinates to find trig ratios, basically. And so you have this on your note sheet. You also have this on your master formula sheet. It is something you will use nearly every single day, the whole rest of the trimester. You'll get really used to this. You'll have it memorized probably before we do this. You know SOHCAHTOA, you know that sine is opposite over hypotenuse. And then there's also some other things here. These 3 trig functions over here you probably have not heard of. Maybe some of you have. But this is cosecant. It's the abbreviation for cosecant. This is secant. And this is cotangent. And I purposely lined these trig functions up this way because I want you to notice what's shaken down here. If you compare these two and you look at their ratios, sine is y over r, or 1 over cosecant, or opposite over hypotenuse. Cosecant, on the other hand, is the reciprocal of that. It's r over y, 1 over sine, or hypotenuse over opposite. So I lined them up. Cosecant is the reciprocal to sine, secant is the reciprocal to cosine, and cotangent is the reciprocal to tangent. Okay? So just kind of notice that. All right, the first thing we're going to do, this first problem, is I want you to be able to find the exact values of all 6 trig functions at 11 pi over 2. And I'm going to split screen this if I can here. At 11 pi over 2, maybe I can't split screen it. At 11 pi over 2, what will happen is you first of all have to figure out where 11 pi over 2 is. And for some people, that's the hardest part, okay? 11 pi over 2, if you think about that, and you cut it in half, is a mixed number. It's the same as 5½ pi. Okay, so same as 5½ pi. And so what you're going to do is you're going to start right here, obviously, and I'm going to go, there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and another half of a pi puts you down here. So you're down here, and you're going to use these coordinates, 0, -1. Okay, you're going to use 0, -1 down there. Okay, so when you do sine, your sine value from that trig ratio sheet, if you look, your sine is your y value over your radius. Well, if your coordinate is 0, -1, your y value is -1, your radius is 1. Anywhere on the unit circle, your radius is 1, and so you'll have -1 over 1, which is -1. Okay? And I'm not going to do all of these, but your cosine is your x value over your radius, and your x value is 0 at that spot, and your radius is 1. 0 divided by anything is 0. Okay? And then your tangent is your y value over your x value. So tangent is y over x. My y value is -1, my x is 0, and remember that you can't divide by 0. So when you have -1 divided by 0, that's impossible, and your answer will be undefined. Okay? And you could keep going, you could keep following that little note sheet and looking at your trig ratios and plugging in the formulas and going. Okay? We are going to do another one here. Let's look at the exact values of all 6 trig functions at 23 pi over 6. Okay? So again, 23 pi over 6 is, the first part to that is to figure out where you are. 23 pi over 6 is the same as 3 and 5/6 pi. Okay, 3 and 5/6. So if I follow this, there's 1 pi, 2 pi, 3 pi, and then another 5/6 of a pi would put me right here, down here. Okay? What I want to think about then is making myself a handy-dandy little triangle. Okay? My angle that I'm talking about is right in here. Your angle always has to be the one that's hooked to the origin every single time. Okay? This is my radius. I know that my radius is 1. So I know that my radius is 1. Some of you like to think in terms of opposite hypotenuse adjacent. So in that case, this would be the hypotenuse because it's opposite the right angle. This is maybe hard to see. I'm going to try and make this a different color and see if that helps. Okay. This side over here is your y value. It is also your opposite. Okay. Now I had to go down 1/2 to get to this spot right here. So my y value is -1/2. It is also my opposite. Okay. This distance right here is my x value, which I know is the square root of 3 over 2. It is also my adjacent, for those who like to think in that way. Okay? Opposite and adjacent, they are. All right, so now that we know that, we are going to use that to find some trig functions over here. Okay? So, let's see. Sine at 23 pi over 6. Sine you can think about as either your y over your r or opposite over hypotenuse. Okay? Either way you think about that, when you go back to your handy-dandy little triangle, your y is -1/2 or your opposite is -1/2. Your hypotenuse is 1. Okay? I keep going the wrong direction here. So, opposite or y is -1/2. Your radius or your hypotenuse is 1, and you'll clearly get -1/2. Okay? I am going to skip to tangent right now. I think you can handle cosine. Okay? tangent is either your y over your x, or it will be opposite over adjacent. And if you do opposite over adjacent, or y over x, it'll be negative 1/2 over the square root of 3 over 2. Okay? Opposite over adjacent, or y over x, would be negative 1/2 over the square root of 3 over 2. Negative 1/2 over the square root of 3 over 2. Okay, now I won't let you have double fractions, so that means we get to simplify this a little bit. So what we can think about doing is this. Instead of dividing by the square root of 3 over 2, I am going to multiply by its reciprocal. So I'm going to multiply by that. My 2's will cancel. And what I'm left with is this, negative 1 over the square root of 3. Okay? Now I can't have a radical in the denominator. And so when I can't have a radical in the denominator, I multiply by itself, and I will get negative root 3 over 3. So that's the tangent value at that spot. Okay? And I think you guys can follow these formulas and fill in. I'm not going to do all 6 of them, but I want you to kind of get a taste of how to simplify some of these. So that's that spot. All right, and I think that that might do it. If I was going to do, let's see, I'm going to go back here and just show you this. If I was going to do this spot here, let's say I was going to do at pi over 4. Okay? If I was going to do pi over 4, and I was going to make a handy-dandy little triangle right here, so I'll make a triangle. My theta, again, always has to hook to my origin. This is my radius, which is 1. It is also my hypotenuse. This would be opposite of my angle, because it's not touching it. And this distance right here is square root of 2 over 2. So it is opposite. It is also my y value. Okay. This distance right here is my adjacent, or it is also my x value, and that distance is also square root of 2 over 2. Okay, so I'm just going to practice simplifying these just a little bit. If I wanted you to do, let's say, cosecant at that spot. Okay, cosecant would be your r value, or your hypotenuse, over your y value. So this would be the hypotenuse, and my y value is my opposite. If I were to do that, I would have 1 over the square root of 2 over 2. Okay? Again, I cannot, I don't want to have a double fraction in there. So instead of dividing by a fraction, I will multiply by the reciprocal. When I multiply that out, I have 2 over root 2. Sorry. Can't leave a radical in the denominator, so I multiply by root 2. So then I have 2 times root 2, and 2 times root 2 is that. And then on the denominator, root 2 times root 2 is root 4, which is 2. And then these two 2's will cancel, and I will have root 2. Okay? So that's one thing that happens. If I asked you to find cotangent at that spot, at pi over 4, cotangent would be x over y, or if you wanted to think about it as adjacent over opposite. Okay, adjacent is root 2 over 2, opposite is root 2 over 2. Don't make this any harder than it has to be. You can sit and flip these if you want, but if you have the same number over the same number, guess what you have? 1. Okay, and that would be that. So that's all the ways that you need to worry about simplifying these right now. We will talk more about this tomorrow, but hopefully this is enough to get you going.